Hey, what's up, guys? So for this week, we're going to be talking about 4.6 inverse of functions. So we talked about last time a little bit about what functions are, right? We touched on it. So again, we're going to do a quick review because this information is very important. So we talked about how f of x is a function. Now, f of x itself is the output variable. And x is what we call the input variable. Okay. Now, f of x is just another fancy way of describing y. So f of x is equivalent to y. And a lot of the times, and most times, we write y in terms of x. So f of x is a function in terms of x. So meaning that, like, say for example, I have y is equal to x plus 2, or in other words, f of x, right? F of x is equal to x plus 2. You can see that y, or f of x, is written in terms of x plus 2, in terms of x, okay? So basically, we're just saying that y, right here, is equal to an equation in terms of x. So it's just expressed differently and in different variables. Now, so what we're going to be doing today is we're going to find an equation for the output. So this right here, or for the inputs, this right here, f of x and y, is expressed in an equation in terms of input variables, right? So if we wanted to find the value of y, we would first need to input a value right here, input an x value. Now, can we, and this is the goal for today, is find an equation for the inputs rather than the outputs. Because these right here, these are equations for the outputs using inputs. So can we find an equation for the input? So meaning x is equal to something in terms of y. Okay, so that's what we're going to be doing today. So let's go to this first example where it says write a formula for the input of a function. So again, not the output, for the input of a function. So this right here, f of x is equal to 2x plus 3. So we want to solve y equals f of x for x. And what this basically means is that we're going to take this equation right here. So let's write out a process. So take f of x and rewrite with y. So right here we're going to take f of x is equal to 2x plus 3, but we're not going to write it with f of x, we're going to write it with y. So y is equal to 2x plus 3. Remember, they're equivalent, so that's okay. Now we want to solve this equation right here, so we're going to solve y equals f of x. We're going to solve it for x. So let's take this equation right here. This is an equation right here for the outputs. We want to find an equation or a formula for the inputs. So let's give that a go. And all we have to do is solve for x. 2 is solve for x, which basically just means we're trying to get x all by itself. Okay? So if we want to get x by itself, let's use operations of inverses and for algebra. And so right here, I could subtract 3 from both sides. See right here, these cancel, and this becomes y minus 3, which is equal to 2x. Again, the goal is to get x by itself, so this is 2 times by x, so let's do the opposite of multiplication and divide by 2. But if I divide one side by 2, I have to divide the other side by 2. And thus, I get y minus 3 over 2 is equal to x. And if I want to write it as if we're reading left to right, I'll write it as x is equal to y minus 3 over 2. So this right here is A. We just solved y equals f of x. We just solved the equation for x. And now, so you see here, this y is equal to 2x plus 3. This is an equation that gives you the outputs. However, this equation down here that we just found in terms of x, this is an equation for the inputs. So basically, if we had a y value and a y value, we could use that y value and find the input. So it's just basically just the other way around, right? Okay, now notice here, let's look at the two equations that we have. Okay, so we're going to go back to saying f of x. So f of x is equal to 2x plus 3. And we're going to call this function, we're going to make it into a function, g of x. So we're going to say f of x is equal to 2x plus 3, and g of x is equal to x. We're going to change this into terms of x. So x minus 3 divided by 2. Now, let's look on the left side first. And let's talk about what's happening to the x value. What are we doing to the x value? So first of all, we are multiplying by 2. So timesing by 2. And secondly, we are adding 3. Now let's talk about the right side. Notice on the right side, first thing that's happening to the x is that we are subtracting 3. Subtracting 3. And the second thing that's happening is we are dividing by 2. Okay, so do we notice anything that's happening here? So notice here that here, if you look at it crosswise, these steps, they are inverses of each other. So for the first step here, we had multiply by 2. And then here, the last step, here the first step was multiply by 2. Here the second step, the last step, is dividing by 2. And then the second step here, which is add 3, is actually the first step here, which is subtract 3. So notice that the operations are inverse and the order of the operations are opposite. This is what we call inverse functions. So these right here are inverse functions. These are inverse functions. Now right here is a table and a graph of both these functions. So here's f of x and here's g of x. F of x is in blue, g of x is in red. Now, let's notice some patterns that we see here. Let's talk about the patterns that we see first in the tables right here. And hopefully what you notice here, this right here, x is negative 2, y is negative 1. But down here, x is negative 1, y is negative 2. If you keep going, this is negative 1, this is 1, but the x here is 1 and the y is negative 1. So the difference between inverse functions is that their inputs and outputs are reversed. They are changed. You can see that here. So here, this whole x column, which is the input column, in the inverse function is the output column, or output row, sorry. And here the output row in the original function is now the input row in the inverse function. and that's why they're inverses of each other. And you can see that whenever you graph them, here are the two lines, right? So here's f of x and here's g of x. Now, if you have inverse functions on a graph will be mirrored across the line y is equal to x. So here's the line y is equal to x. Notice that these two functions are mirrored opposites across that line. And that's because they're inverses. So, now let's come down here. First thing I guess we forgot to do here, we need to find the input when the output is -7. So what we would do here, so we want to find the input. Input is x, output is y. So output is y. So we can use this equation right here. So if we want to find the input, remember that x is the input, we want to find the input when y is -7. So that means x is equal to -7 minus 3 divided by 2. So then the input is -10 divided by 2, which is equal to -5. So the input for the function is -5 when the output is -7. Now you could have easily have done the same thing using this equation. You would have gotten the same answer. Alright, now let's go down to this page right here, and we're going to be looking for inverse functions. So find the inverse of a linear function. This right here is a linear function, 3x minus 1. Okay, now if we're going to find the inverse, we're going to do the exact same thing that we did up here. We're going to find a formula for the inputs, and to do that, this is what we do. We take y equals 3x minus 1. So we're rewriting this as f of x is equal to y instead. Okay, so again, rewrite with y instead of f of x. Okay, second is we're going to swap y and x. We're going to swap y and x. Okay, so here I'm going to rewrite this as x is equal to 3y minus 1. And 3, we are going to solve for y. Okay, let's do it. So here we're going to add 1. So then we have x plus 1 on this side, and then here we have 3y. I'm going to divide by 3, and then I'm going to write my y on this side because I like having it on the left side, but here they cancel, so that's why I'm left with y, and then here I just have x plus 1 divided by 3. And there you go. Y is equal to x plus 1 divided by 3. So this right here is the inverse of f of x. Now generally when you write it as an inverse function, we want to express this actually in terms of g of x. So g of x is the inverse of f of x. So right here is your inverse of f of x. And that's really all you have to do for all of these. So even if it's a quadratic, or if it's a polynomial of degree 3, or polynomial of degree 4, or polynomial of degree 5, all you got to do is follow these steps up here. So rewrite the equation with y is equal to x squared. Okay, I want you to ignore this part right here. We're not going to be doing any graphing. Y is equal to x squared. And then we're going to swap the locations of x and y. So now it's going to be x is equal to y squared. And we're going to solve for y. So here, to get y by itself, I just have to take the square root. And then this is going to be y is equal to, now remember that whenever you take the square root of a number, you get both the positive and the negative. Okay? So this means I'm going to have plus or minus the square root of x. Now I think we talked about this a little bit in 4.3, maybe just a tiny little bit, not by much if we did. But yeah, so if we were to graph this, which I think we did before, so y is equal to, remember that this is two different ones, right? So this is like saying y is equal to the square root of x and y is equal to negative square root of x. Okay? Now, if we were to plug that into a graphing calculator, okay, we'd get the square root of x and the negative square root of x. So there you go. So right there, that's what the inverse functions look like. Except for our case, we're actually just going to ignore this part right here and just keep it as the positive. Okay? So in this case, let's just ignore the plus or minus. But that's how you pretty much get a sideways parabola, is by doing that. Okay? So y is equal to the square root of x. So we're going to write this as g of x is equal to the square root of x. And this right here is the inverse of f of x. It is the inverse function. Okay. Now, I feel like that's really straightforward and simple. Just need to follow these steps whenever you're solving for inverses, is to rewrite with y instead of f of x, swap the locations of y and x, and solve for y, and that's how you get an inverse function. Now, last but not least is confirming and verifying functions are inverses of each other. So right here, it gives us f of x, which is 3x minus 1, and g of x, which is x plus 1 divided by 3. Now, we're going to confirm that these are inverses. Now, just as the definition states, pretty much if these are inverses, then f of g of x will equal x, and g of f of x will equal x. Now we talked about compositions. These are compositions. We talked about that last time. So if these are inverses, this is how to verify. So verify with compositions. Now let's try it out. So we're going to do f of g of x, and we did this last time. So this means we're going to take g of x and plug it into f of x. So this is equal to f of, this will be 3 times g of x minus 1. And g of x is equal to x plus 3, so this is equal to 3 times by x plus 1 divided by 3 minus 1. Now if we simplify this, those 3's cancel, so then we have x plus 1 minus 1, and these cancel, so then it's equal to x. So f of g of x is equal to x. So far so good, but we have to make sure that it works the other way around. We have to make sure that g of f of x is equal to x. So now we're going to take f of x and plug it into g of x. So this would be equal to f of x plus 1 divided by 3, which is equal to, now f of x is just 3x minus 1, so 3x minus 1 plus 1 divided by 3. And this is equal to 3x minus 1 plus 1 divided by 3. These cancel, so it's equal to 3x divided by 3, and that's equal to x. So there you go. we just verified that these are indeed inverses of each other. F of x and g of x are inverses. Okay. And that's pretty much it. Really simple, straightforward lesson, and now you know about inverse functions. Okay. Now, if you have any questions, let me know. Send me an email, or I'll just see you in class. Thanks.